Hello, this video is for students taking the laboratory, and what you all are working on now is Lab 5. Lab 5 deals with substitution reactions, and before I move on, let me maximize my screen a bit by getting rid of this tab on the left. Okay, good. And, well, let's just look at the handout right away. Oh, before I do that, while I'm on Moodle, your notebook and post-lab submission will be due on Wednesday at 5 o'clock. Now let's take a look at the handout. SN1 and SN2 timing. Basically what you're doing in this lab is you're running two tests to figure out what unknowns 1 through 4 are, and these are your choices. We're doing substitution reactions, and there you know that there are two types of substitution pathways, SN1 and SN2. SN1 we're going to use an alcoholic silver nitrate test. For SN2 pathways we're going to use the sodium iodide in acetone test. Now I want to talk a little bit about your alkyl halides. You know that this is primary, this is secondary, and this is tertiary alkyl halides. But this is considered an aromatic halide because it has a ring that's considered aromatic. Now don't worry about what aromatic means. What you should know is that benzene rings are considered aromatic, and if you have a bromine or a chlorine directly attached to the benzene ring, that molecule is an aromatic halide. We've heard about benzene before, this ring over here, because we did talk about the stability of a benzylic carbocation. But if you recall, a benzylic carbocation, the plus charge is not on the ring. The plus charge is on the carbon that is attached to the ring. So we do not have a benzylic carbon in this molecule. This is bromobenzene. This is not benzyl bromide. Okay, so let's set that aside. We do not have a benzylic carbon, so we're not doing any substitutions on a benzylic halide. Now, I threw this molecule into the experiment because this molecule does not react in substitution reactions. That's something that you should memorize. And specifically, you could memorize this. Substitutions do not happen at an sp2 carbon. That's sp2 right there. All the other carbons attached to the halide are sp3 carbons, tetrahedral carbons. Okay? We're not going to get into why you don't substitute at an sp2 carbon. It's just a rule that you have to remember. What follows is that you don't make a carbocation at an sp2 carbon, okay, for an SN1 pathway. And a nucleophile does not attack an sp2 carbon for the SN2 pathways. Okay, so in both tests you would expect no reaction, even if you heat it and leave it in heat for more than 5 minutes. There should be no reaction with this bromobenzene. Let's take a look at the two tests. Now, the first test favors or gives us conditions that would favor SN1 pathways. That's because we have a weak nucleophile, water, and we have ethanol, which is the solvent. Now, how do I know water is the nucleophile? Okay, because of the product that we get. So this was experimental, and when we ran this reaction with these four molecules, we mostly got alcohols. So here's your OH. That OH came from water, and technically OH is not the nucleophile. Water is the nucleophile. Water attacks the carbocation that we see here. See, there's your nucleophile, and in the last step, a proton is removed to give your product. Now, there's another reaction that forms a precipitate, but that reaction is just showing us that the reaction is happening. And you are timing this reaction until you think no more precipitate is being formed, and that's when you stop your stopwatch. Okay. Now, I put a tertiary alkyl halide here because those react the fastest. Am I saying that a primary alkyl halide won't react? No, it should react, but it will react very slowly. Okay, is it going through an SN1 pathway? Most likely not. Okay, it's probably going through an SN2 pathway, and that's why it's slow, because we have a very weak nucleophile. Okay, so it's still a test that tells us whether we have a tertiary, secondary, or primary alkyl halide based on the speed. Now the opposite trend occurs for SN2 pathways. The primary alkyl halide reacts fastest, and we're favoring an SN2 pathway because we have a very good nucleophile, I-, and we're running this reaction under polar aprotic solvents, acetone. You'll do that reaction, or those set of reactions, 4 unknowns, 2 tests, so at a minimum 8 test tube tests. Okay. Let's take a look at some data, because obviously we're not in the lab together. We're going to use data from a previous semester. Their observations aren't great, okay, because here it looks like we have the color, but not the clarity. It could be cream and transparent. Here we have cloudy, but we have no color. What can you do? How do I read this data? So there are 3 groups, or 3 people, that did the silver nitrate test on unknown number 3, and this is their data. I believe that this minute is how many minutes they had the reaction under 50 degrees. So the procedure says to start at room temperature. If there's no precipitate for a couple of minutes at room temperature, then the procedure says to put it in a 50-degree water bath for X amount of time until you get complete reaction, until you think no precipitate is being formed. So one group says it stopped forming at 1 minute, other groups use all 5 minutes. The results are inconsistent between groups, but that's real data. Okay? And you want to take sort of an overview or an average of the data. All right. For unknown number 1, here they have RT. That's room temperature. Oh, in 2 seconds at room temperature, they felt that they made as much precipitate as possible, or precipitate stopped forming, and the precipitate was white. Okay. It seems like all 3 groups did number 1 again just to double check, because that was maybe a surprising result to them. Or maybe they wanted to confirm with the other test what molecule they think number 1 is by doing number 1 again for the silver nitrate test. Okay. I don't know if I mentioned it. The silver nitrate is just a helper molecule to stabilize the carbocation, but also to couple a precipitation reaction to the substitution reaction. I think that's the main reason why we have silver nitrate, because it will react with HCl to form a precipitate, and that is kind of announcing that this reaction is actually happening. Okay, we wouldn't form HCl if this substitution was not happening. Okay. All right, so that's the data that you are going to try to interpret. And you're going to use that data to answer post-lab question number 1, or problem number 1. Identify which compounds are 1 through 4. No explanation needed. And you'll answer the rest of these post-lab problems as well. Let me talk about the notebook. I want to keep this video under 15 minutes, hopefully. For the notebook, I'm noticing something about everyone's, or almost everyone's, purpose. What is the purpose of the lab? The purpose of this lab, okay, is not to understand SN1 and SN2 reactions better. The purpose of this lab is not to learn how to do a test tube test. Okay, I'm telling you that the purpose of the lab is to identify 4 unknowns using 2 substitution tests, one favoring SN1 pathways and the other favoring SN2 pathways. Okay, so do you see what my purpose is saying? My purpose is literally telling you what is being measured, what is being recorded, what is being observed, what is being synthesized if we're doing a reaction. Okay. Again, a good purpose for this lab is to identify 4 unknowns based on substitution reactions using 2 types of tests. One test favoring SN1, the SN1 pathway, the other test favoring the SN2 pathway. If you want to be a little more specific, you could say the purpose of the lab is to identify 4 unknowns using the alcoholic silver nitrate test, which favors SN1 pathways, and the sodium iodide and acetone test, which favors SN2 pathways. Okay, so I'm trying to cram in, some terminology into my purpose, but I'm also keeping it kind of short. Okay, to the point. What are we doing? What are we recording? What are we measuring? Okay. Let me take a look at and show you lab number 3, just as another example. Okay, because I want everyone to understand what a purpose is. This was the lab where I asked you to read literature. Now, yeah, the literature is showing you examples of acid-base extractions using colorful compounds. And hopefully the student does learn how to do an acid-base extraction, or hopefully the student does appreciate how an acid-base extraction works. But I asked you to write up the procedure for part 2. What is the purpose for part 2? The purpose for part 2 is to literally to transfer the molecule neutral red from the aqueous phase to the organic phase using an acid-base extraction technique. Okay, I add a little bit more, which in this case deprotonates the aqueous soluble neutral red plus species to form the neutral red neutral species. Okay, again, the purpose is not to appreciate acid-base extractions. The purpose is not to understand that charged molecules go into the aqueous phase and neutral molecules go into the organic phase. Okay, the purpose has to tell me what you are doing, okay, and why you are doing it. What is actually happening? What is actually being done, recorded, measured? Again, the literal purpose for this procedure, part 2, is to transfer neutral red from the aqueous phase to the organic phase using the technique acid-base extraction. So I do mention the technique, okay? I do mention the technique, but I'm also mentioning the actual molecule. All right, let's take a look at lab 4. This one, the purpose for this synthesis of polystyrene was very easy. Again, it's not to study radical reactions. It's not to be safe while doing a reflux technique. The purpose for this lab, I would say, is to literally to synthesize polystyrene via a radical polymerization under reflux. So I did mention the type of reaction that you're learning. I did mention the type of technique that you want to practice with. But the purpose is really literally to synthesize polystyrene. Okay, that is what I'm looking for in a purpose. Okay, what are you doing? Okay, not what are you learning? Okay, there's a difference between those two. For me, one is the purpose, and the other one is a goal or is an aspiration. Okay. Okay, so I'll let that simmer for a little bit. Make sure you write an adequate purpose for this lab 5. Everything is due at 5 p.m. Oh, one last thing. Because I am going to send you the answer key, or the answer keys are already posted on Moodle. But for lab, was it 3? Yep. For lab 3, what I expected for the cartoon and the equation underneath your title was this. I asked you to do the procedure for part 2. So you should have assumed that the equation for part 2, the chemical equation, was this one right here, the second one. Okay? Because, man, not a great picture. Let's see if I can find a better one. I wasn't expecting people to draw this reaction on the left, because part 2 was using neutral red, it wasn't using phenolphthalein. So underneath the title, what I expected was this chemical equation with the structures, and for those who got full credit, also the here it is, the schematic or the cartoon for the actual separatory funnel. Okay. All right. I think that's all I want to say right now for this video. I'm a little bit over. If you have any questions, let me know. I will, if I haven't yet, I will email you your graded exams. Oh, it's not exams. Your graded lab, post-lab and notebook. But the answers are up already. So if we go back, those answers are here. So answers for lab 3 are here, and the answers for lab 2 are also here. All right. Okay. I'll see you all Wednesday at 10 a.m. and the lab stuff again is due at 5 p.m. on Wednesday. So if you have any questions, you could definitely ask me at that time during our Zoom session. All right.